Okay, today we're going to do a review of part 1 of Unit J, circulation, which is looking at the blood vessels and the tracings. So let's start. Just going to point out not all of them because the diagram could do that for you, but definitely we should be able to label them and understand where they're going and what kind of blood they're carrying, O2 blood or low in O2, and that would be high in carbon dioxide. Just a couple of reminders. There's two circuits, the pulmonary circuit, which the arteries and veins are going to be backwards in terms of the type of blood. The systemic, the major circuit of the body that goes out from the aorta, the major artery of the body, right, to the body cells, and then returns back to the heart. So heart to the body and back again. Just pointing out renal. On this one, I would call them a matching set. Renal as well, when there's two of them. Inferior is the one below. Superior, the one above. On this one, not showing us the coronary arteries. I think I might have mentioned that in another one. I know I did. Those are the arteries and veins that travel to and from the heart. Everything else I think is pretty straightforward. So let's go ahead and compare, review the basic structures of our arteries, our veins. So remembering blood flow starts in the heart, goes through the arteries, arterioles, through the capillary beds, where exchange is going to occur. Exchange of nutrients are going to exit the blood, and wastes are going to enter the blood. So it's an exchange. It's a swap, right? The nutrients get out, the wastes get in to the blood. Then the vein, once it's spent, we could say that, it's used up, it's going to return back to the heart through the veins. So why do I say that? Because we need to know that in the arteries, blood pressure is highest. Therefore, the arteries are designed to withstand this high blood pressure by having thick walls, by having elastic walls so they can recoil. They can also constrict and dilate to help in the regulation of blood pressure. Going on into the capillary beds, we want to know that the capillary beds, blood flow into the capillary beds controlled by sphincters. Just like in our digestive tract, these are valves that can open or close. So if we were freezing to death, blood flow shuts off to the appendages, right? Our fingers get frostbite first because the blood flow is going into the body core. On the other side of the capillary bed, venules, veins are thinner walled. Blood pressure is lower. The elasticity is not as important, and they have valves to prevent backflow. This is an important graphic. I would invite you to look at this as a helpful understanding of how blood pressure, velocity, the speed, and total area change as we move through arteries and onto veins. Just going to show you the major trends. So arteries, we find that they have the highest blood pressure. We already said this is due to proximity to the heart. As we move away from the heart, blood pressure drops continuously. And so as we arrive in the veins from the arteries, we see blood pressure is lowest anywhere in the body, lowest in the veins. Let's look at total area. We could think of it as cross-sectional area, circumference, but we have to understand the area means the area that the blood is going to flow along, travel along. So it's like if we're talking about highways, the surface area of the highways. So the capillary, no surprise, have the highest cross-sectional area. Why do they win this prize? Because they are the most numerous, right? They are found everywhere. That is the reason why, though. They're the most numerous. That's the reason why they have the most area. Why is this important? To allow for exchange of nutrients and wastes. As we move into the veins and the arteries, they're about the same, similar cross-sectional area. Just quickly looking at velocity. Velocity increase is high in our arteries as we move across the capillary beds, and you could think of a hose, right? When you put your hand right up on the hose, you can create a lot of pressure. As the water moves away from you across the lawn, if you're spraying your hose, the pressure decreases, the water moves slowly. And in here, why does this velocity increase? It's to do with this area. So when you put all the blood over a higher area, it's going to decrease the velocity. As we move back into our veins, the velocity picks up again. It's not as fast as our arteries, but however, it does pick up. Okay? Again, encourage you to spend some time looking at this. Headless man diagram, the two I'd point out to you on this one, sorry, going back quickly. Hepatic portal, the one between the digestive tract, high in nutrients after we've eaten a meal. So after we eat a meal, this would be the highest nutrient blood in our body. Between meals, meaning like before lunch, before dinner, on this side, we would expect this to have high glucose as glycogen is broken down by the release of glucagon. If you don't know what I'm talking about, go back and listen to, watch the little clip on blood sugar regulation. I'd highly encourage you do that. Fetal circulation, fetal 4. Fetal 4 are the 4 modifications. We should know where they are. We should know what they do. Okay, so the umbilical cord contains the vein. We remember the vein has high O2. It's headed in to the baby's body, right? Just like the pulmonary vein, highest oxygenated blood, most oxygen-rich blood in the body. Umbilical arteries, they're heading out. They're heading from the fetus to the umbilical, to the placenta. So they have low O2 and they have high waste. High waste. As we enter the venous duct, bypassing the liver, oval opening, the hole in the heart between the right and the left atrium, bypassing the lungs. Above the heart, I say above to concentrate on that A, arterial duct, also bypassing the lungs. So these two have the same function. They share that. As a little exercise, you could sit down and list the right atrium to the kidney. Can you do that? You should be able to. If you can't, ask somebody for help, get it figured out. Hope to help. See you soon.